for this particular function here, find an equation of the line tangent to the graph given of g of x at the point when x is 0 and y is 2. So they want an equation of the line tangent to. That means that tangents can touch at one point, and a strategy is going to be to find the first derivative of g of x and then evaluate it at the point where x is equal to 0 and 2. So to start out with, there's my original function. It's an exponential there, so I have to do the derivative of that. So I'll write this out and I factor out my constant. Then I take the derivative of the function exponential here. So I have 2 times e to the u, derivative of e to the u. It's going to be 2 times e to the u du. In this case, my u is negative 8x, so my du is going to be a negative 8. So when I find my derivative here, I have 2 times e to the u, negative 8, times the du, which is negative 8 here. And that gives you my equation. So they want to know what the slope is at that point. And in this case here, they want it in slope-intercept form. And slope-intercept form is right here. Y is equal to mx plus b. So let's find the slope when x is equal to 1. So I plug in here for 0. X is 0. So I plug in for 0 here. Anything to the 0 power is 1. So I have minus 16 for my slope. So I have a slope and I have a point. I can get an equation for the line now. I need to know what b is. So I plug in here my slope, which is negative 16. My x coordinate is 0. My y coordinate is 2. So I find my y-intercept to be 2. So now I know what my slope is. I know what the y-intercept is. I can get an equation for the line. I know the slope, but I know the y-intercept. There's my equation for the line.